All right, in this lesson, we're going to be looking at function transformations. So the general format for a function is going to be a times some quantity, 1 over b, times f of x minus h plus k, where a causes the parent function, the graph, to either stretch or compress vertically. If a is greater than 1, then it's going to stretch the function vertically. If a is between 0 and 1, a fraction between 0 and 1, then it's going to compress the function vertically. And if a is negative, it's going to reflect the function vertically, meaning it's going to reflect it across the x-axis. Now b is going to either stretch or compress the function horizontally. So if b is greater than 1, it's going to stretch the function, the graph, horizontally. If b is between 0 and 1, it's going to compress the function horizontally. Stretch means to make it bigger, compress means to make it smaller. And if b is negative, that means that the graph is being reflected horizontally or reflected across the y-axis. H moves or translates the parent function. It translates the parent graph horizontally. So if h is positive, then it's going to translate it to the right. If h is negative, it's going to slide it to the left. Now keep in mind, if inside the parentheses you have x minus 3, that means that 3 is positive. All right, the format is x minus whatever h is. So if you have x minus 3, that means 3 is positive, and that's going to move the graph 3 units to the right. If h is negative, it's going to move it to the left. And then k translates the graph vertically. So if k is positive, it's going to move the graph up that many units. If k is negative, it's going to move the graph down that many units. All right, so if we have a graph and we want to translate it to the right 3 units and up 4 units, that means we're going to be adding 3 to all of the x coordinates and adding 4 to all of the y coordinates. And the function should look like g of x. The image, once it's translated, should be g of x equals, a should just be 1 since it's not being stretched vertically, and then f of x minus h. It's being moved 3 units to the right, so that means h is 3, so we should have x minus 3 in the parentheses. And then it's being moved up 4 units, so we're going to add 4 after the parenthesis. For this example, we want to compress the parent function vertically by a factor of 1/4. So that means that a is going to be 1/4. Whenever we're compressing it vertically, we're just going to multiply all of the y coordinates. Since it's being compressed vertically, we're going to multiply all the y coordinates of the pre-image by 1/4. And then again, a is 1/4, so we should just have g of x equals a, which is 1/4, f of x. 3, we want to reflect it across the x-axis, so that's a vertical reflection. So that means that a is negative. Since it's not being stretched at all, we should just have -1 for a. So in essence, we're just changing all the signs of all the y coordinates. Change the sign of all the y coordinates to reflect it across the x-axis. And the function should look like g of x equals -1 f of x, except we just don't write the 1, negative f of x. And then example 4, we want to stretch vertically. So we're going to stretch vertically by a factor of 3, so that means a is 3. And we're going to shift it to the left 2 units. So that means that h is -2. All right, to write down all the coordinates of the image, we would multiply each of the y coordinates by 3. That will stretch it vertically by a factor of 3. And then we're going to subtract 2 from all the x coordinates since it's being shifted 2 units to the left. And the function should look like g of x equals, again, is being stretched vertically, so a is 3, f of x, and then it's being shifted 2 units to the left, so x minus -2, which is x plus 2. And then it is not being shifted up or down, so k is just 0.